Okay, let's get started. So welcome to the third webinar of the day with Nomad and LINSTOR. Today we're gonna go over a live demo. We've got Thomas again. He was with us in the previous webinar. And we've got Yusuf, solutions architect here at LINBIT, and we've got Moritz, who's one of our developers who focuses on the Kubernetes integration of LINSTOR. Thomas, do you want to go ahead and start?
Absolutely. Thank you very much, Brian. Let me share my screen. I'm Tom Harris. I'm a solutions engineer from HashiCorp. And if you haven't heard of HashiCorp, we have a software stack that enables the provisioning, securing, connecting, and running of applications and the infrastructure to support those. Okay, and something that we call the cloud operating model, ultimately. Okay. Today we're talking purely about Nomad, really, with no focus on those other tools and sort of the LINSTOR integration with Nomad. Nomad is a simple workload orchestrator that's designed to deploy and manage containers and non-containerized applications across all different cloud providers and at large scales as well. And that's one of the sort of the guiding principles of Nomad, and what differentiates Nomad between other orchestrators is the fact that we can do these non-containerized applications. So you've got a single plane and a single workflow for orchestrating applications. As with all HashiCorp products, one of the core principles is sort of as code approach. Terraform is infrastructure as code. This is application deployment as code. It takes on the same language as Terraform, which is the HashiCorp configuration language. Okay, and within these job files that are submitted to the Nomad API, we can configure all of our applications in the same fashion, and we can also integrate storage into those applications too, and present storage block storage volumes to application containers or just the host. And one of those integrations is obviously LINSTOR CSI driver, which you'll be hearing out a lot more. So this vision is this Nomad being a single orchestrator across all different cloud providers, and also your on-premise estate for all of your applications. It's a super lightweight binary that just runs on a Linux VM ultimately, and really easy to get up and started with. Got many sort of well-known public users of Nomad, some well-known names there who are seeing sort of large benefits from running Nomad to orchestrate their application estates. And with that, a very brief introduction to Nomad, I shall pass over to the next speaker.
Thanks, Thomas. I think I'm taking over from here. Let me share my screen. Okay. So hello, everyone. This is Yusuf from LINBIT, and I'm working as a solution architect. And let me give you a brief introduction about LINBIT SDS and our integration with Nomad and why it is beneficial. So LINBIT SDS is a software-defined storage solution that is built in LINBIT's by developers. And as you can see on the right-hand side, LINBIT SDS has a component, what we call a main component, what we call LINSTOR. And the LINSTOR is basically consists of two different software. One of them is the LINSTOR controller, the other one is the satellite. And the satellite is basically installed on all nodes, and the controller can be anywhere in the cluster. So we have some high availability capabilities within LINSTOR. And with LINSTOR, as you can see on the right-hand side, it is already connected with Nomad through CSI driver. And in LINSTOR's context, the controller mainly controls the satellites, and satellites mainly controls the nodes. And with the storage inside, And in LINSTOR's perspective, the resource volumes reflected as a backend volumes in Nomad. And LINSTOR has many advantages, which I will explain in the next slide. But it's mainly focused on using the storage in the worker nodes or storage nodes and use them as a persistent volumes or volumes in such clusters. So I will switch to the next slide, the benefits. There are many overlaps between LINBIT SDS and Nomad actually, and I will go one by one. And I don't want to consume a lot of time here because Moritz after me will do a great demo for you guys. And we already had the LINBIT SDS presentation and the Nomad presentation before this session. So I think they are already recorded and will be published online. If you want to see more detailed explanation, please go ahead and watch them after. So both solutions are open source. This is the beauty of both solutions. And LINBIT SDS is a tailor-made for high performance computing and regular workloads. So we can clearly say that you can use LINBIT SDS in any kind of workloads that you have. But by that means it's not limited to anything. So whatever storage, whatever performance you're expecting, LINBIT SDS can deliver that to you. And the Nomad, on the other hand, it's an open source platform for containers and non-containerized workloads, including high performance computing. And both systems are really simple and learn and to use. So this is really important as a for example, system administration perspective. I mean, there are some other tools in the market, both for storage and the operator side. They are really hard to learn, hard to get used to by. I mean, it's really hard to start using them. But LINBIT SDS is unbelievably easy to install in any kind of workload, and as well as the Nomad. Nomad has a single binary, LINBIT SDS, a single software that you can install and use. So they are both really easy to use in any kind of systems. So it's good for the system administration and development purposes. And LINBIT SDS leverages the common tools in Linux. This is really important also. And it's also using DRBD for replication. DRBD is a distributed replicated block device that we built for more than 20 years now. And that is the fastest replication technology out there. And it basically does the RAID 1 replication over the network within 2 Linux machines. So what you will have in your clusters, for example, a resource will be one-to-one replicated into another machine with DRBD. And that's why it's not using any kind of algorithms to distribute the data. So it's not using the data distribution technologies or algorithms. That's why the replication is fast, reads and writes are fast, and not just DRBD, LINSTOR also use, the LINBIT SDS also use common tools of Linux that you are already used to have it. And that's why it's easier to understand. And both systems have automated deployment. So both Nomad and LINBIT SDS can be automatically deployed into your system. So you don't have to worry about how and when and why kind of things. There are user guides on the internet. You can check it and install however you like. And there are small differences on the distribution side. The LINBIT SDS only supports Linux distributions right now, but Nomad, on the other hand, is available for major Linux distributions, and it's platform agnostic, so it also supports the Windows versions, Windows operating systems. And I already mentioned, but the beauty of Nomad, for example, when you compare it with Kubernetes, And the Nomad is aimed for different scales of production environments. So it can run in low cost as well as high cost environments. And this is same for LINBIT SDS. That means the LINBIT SDS and Nomad is a perfect fit for every kind of production systems out there. I mean, even if you have, if you need to create a low cost infrastructure with automated management, both on storage and the operator side, you can use the LINBIT SDS and Nomad together for having such system. And both systems have GUI and CLI and API support. I mean, this is a de facto, right? Everybody should have that. And you can manage your storage and your Nomad with GUI or from the command line interface if you are familiar with it and if you are fond of it. And both systems have API support, so you can remotely manage and use it. The great part of LINBIT SDS, you can use it in any kind of hardware and you can mix and match different kind of brands. So you can have HP, Dell, whatever you like, Supermicro machines in one cluster, as long as you have the same performance from all of them, obviously. And that's why you don't have to use any fixed machine for your solutions. And I think both goes for Nomad, so you don't have to use any kind of hardware specifically for Nomad. And let's come to the TCO, the total cost ownership. So on the LINBIT SDS side, obviously, LINBIT SDS provides low total cost of ownership compared to others because LINBIT SDS consumes really low CPU and memory. This is because LINBIT SDS is completely separated the data and the control plane. So the control plane is handled by DRBD and the data plane completely handled by DRBD, and the control plane is completely handled by LINSTOR. And LINSTOR is not using, as I mentioned, any kind of data distribution systems, and it's not in the data plane. That means it's definitely not using any CPU and memory because it's only using system resources when you want to create a resource or volume. So that's why it is making your life easier. It is making your purchases easier, so you can find a best way to have a good or low-cost infrastructure. On the other hand, Nomad is also providing low total cost of ownership, but this time they have a different kind of thing than LINBIT SDS. They have low total cost of ownership because they are great in utilizing CPU and memory. They have really smart way to do that. I mean, you can check it afterwards, this presentation. There is good videos about that on online. So instead of having a lot of machines, you can have one or two machines. You can combine in a lot of machines in one or two machines to get great utilization on CPU and memory, and that gives you the ability of having low TCO solutions. And both solutions obviously makes it easier your day-to-day operations. I mean, when you think about storage and the platforms, some solutions only focused on developer side, some solutions only focused on the system administration side. But the solution should always think about both sides. I mean, on the one hand, when you want to make developers' life easier, you also need to make system administrations easier. And LINBIT SDS and Nomad is created this in mind. So when you want to do maintenance, when you want to do upgrade, when you want to do, I don't know, replacement of a hardware piece in your machines, both systems are really flexible on that. So you can easily remove, upgrade, or do your maintenance in your machines with LINBIT SDS and Nomad. These are the things I wanted to share with you about LINBIT SDS and Nomad. It was a short introduction, and I will repeat again. If you want to hear more, please watch the other presentations afterwards when they released. With that, I am handing over to Moritz for giving us a couple of slides and then the demo itself. Thank you.
Thank you, Yusuf. I'll just quickly share my screen. Hello, everyone. My name is Moritz. I'm a developer at LINBIT, and originally I started with integration of LinStore with Kubernetes, and now also in Nomad, as it's kind of using the same technology. To give you a quick overview of what I'll demonstrate today, the LINBIT SDS integration with Nomad has three main components. That's Yusuf already talked a bit about. That's the LinStore controller, which controls the satellites and exposes the API. The LinStore satellites, which
Moritz,
manage. Yeah.
I think you're sharing the wrong screen, maybe.
What am I sharing?
There was not anything, so can you please share again?
Let's try that one again.
Okay.
Can you see it now?
Brian?
No, it looks like we're just getting the lines.
Yeah, it's a dark screen.
Oh, great.
I can share it for you. I can share it for you if you like.
Yeah, but that doesn't help me with the
Demo. Yeah.
Just gonna quickly try if I share. Can still not see anything, right?
Yeah, we're still getting the gray lines.
Oh, great. Choice of running Zoom on Linux.
Yes, that happens quite often.
Try something.
If there are any questions, we can go ahead and start queuing those up. Or if you have any input while we get the screen share working. There's Slack.
We see the Slack, yes.
Yeah, we can see your Slack screen now. Now we see nothing.
Great. Okay, how do we do this?
If you have two different monitors, maybe just disable one for trial.
Yeah, that's what I tried just now, but still seems to not work.
Maybe try re-login again.
Let me try. I'll quickly rejoin.
Okay. In the meantime, I can sing for the audience if you like.
Yeah.
What have you got for us, Yusuf?
I don't know. I told you that we have to find, we have to invent a LINBIT song, you know, so we can sing.
Yeah, one year we had an April Fool's joke that we were going to start a Lin band. I don't think that ever came to fruition yet, but as we add more people to the US side, we do have quite a few musicians that are joining, so it's possible.
I mean, I'm also a musician, so count me in whenever you like.
Okay, I think we got a plan here.
And if
Nope.
WinDRBD becomes a reality, I think LINBIT will definitely become a reality. So.
Okay, Moritz is back.
Yes, we can
Yeah.
see it now.
Great. Okay, let's jump back in then. Or out.
Okay, Moritz, if you're speaking, we can't hear you, but we can see your screen, so it's a start.
It's mute.
Yeah, if I'm muted, then you can't hear me.
Yeah, oh, that's a good point.
Yeah, so sorry for the technical issues. As I was starting to explain, there's kind of three components of LINBIT SDS that are important for Nomad. That's the LINSTOR controller, the LINSTOR satellite, and the CSI driver. CSI is the container storage interface. And if you hear container in there, that's, I guess, an artifact of where it came from the Kubernetes and I think Mesos world, but it's not strictly required to be a container, and it also works, for example, for Nomad host or non-containerized applications. So you don't need necessarily to have containers running. So there are a variety of ways you could deploy LINBIT SDS. You could deploy it as a standalone application and then just connect it with the CSI driver with Nomad. But what I'll show you today in the demo is actually running the whole software stack for LINBIT SDS inside Nomad, because Nomad is already the workload orchestrator, and that way you can easily scale. If you add new Nomad nodes, you already automatically scale LINBIT SDS. You can easily roll out updates. You can have all the benefits of running your application inside Nomad, like monitoring resources and watching logs and so on. And with that, running LINBIT SDS on Nomad is a 4-step process. First, you'll have to prepare Nomad, and then you can deploy the LINSTOR controller, the satellites, and then lastly the CSI driver, and then everything is ready to go. And with that, I'm jumping over to the Nomad UI. As you can see, it's currently completely empty. I have a setup where I have 3 clients, and in this case, just one server node. And I've also configured this. Okay, now I'm on the wrong side. So here. Now I've also got that configured on my command line. And the first step I already said was preparing Nomad. And preparing Nomad, in this case, LINBIT SDS requires some small changes to the default configuration to work. First of all nodes need these 2 host volumes. Just the lib modules folder so that we can load DRBD and all the other maybe not yet loaded storage related kernel modules, and then the /dev directory on Linux nodes, because that's where the storage devices live, and in the end we will need to somehow access storage devices to make volumes work. And then only on the server where we will deploy the LINSTOR controller, we need some place where LINSTOR itself can store some of its internal state. And in this case, that's varlib LINSTOR. And lastly, for the Docker, we will be using the Docker driver in this case. And in order to mount volumes and make them usable, we need to enable the privileged mode for the Docker plugin. And I've already configured all of that in my Nomad setup, so we can jump straight to step number 2, which is deploying the LINSTOR controller. And as I said, this is done inside Nomad. So Nomad, you have job specifications, and here we specify that the LINSTOR controller is running as a service. For convenience, I've said that the LINSTOR controller port is exported on whatever node it is running on. And then here the main thing is that we'll use the Docker driver, and these are the Docker images which are provided to LINBIT customers. There is also the open source variant, which is called the Piraeus project, which you can also find on our website. And as I said, for the controller, we need the volume, the database volume. And let me just quickly start running this first job. And soon enough, it is running. And with that, we can actually start using the LINSTOR API. Okay, maybe it's not running quite yet. Quickly see. Okay, now it must be running. Yeah, guess I was too quick there. And this is the LINSTOR command line client, which you can use to control LINSTOR. And for example, you can see what kind of nodes or satellites are currently registered. And as you can see, we haven't deployed any, so there isn't any, there aren't any satellites registered. So let's get to that. I've got a second specification for the LINSTOR satellites. LINSTOR satellites are deployed as a system job in Nomad, which basically means that they will run on every node that Nomadist knows of, so, or that Nomad controls, and which is actually what we want for our worker nodes. And again, we have this Docker image, which you can use in this case, since it needs to control storage. This is a privileged container, and it needs access to the device directory. Then one thing, as Yusuf mentioned, we use DRBD for replication, and DRBD is basically a kernel module which needs to be loaded on your host. And this is not, you can either install it directly on the host with RPM or dep packages, but we also have a solution if you're only running containers, and there are special containers for all the different distributions we support, and maybe that's a bit of a look into the future. Maybe we don't even need different containers for different distributions in the future. Anyways, this container is started as a pre-start hook. So before the satellite runs, this container will run once, and then the kernel module is loaded, and then everything is fine. And then another thing to show you the power of automation that you can achieve with the LINSTOR API. Every satellite will automatically register with the controller, and this is just achieved with another pre-start task down here, which is using curl to connect to the LINSTOR controller. So let's get started with the satellites. Run that again. And they should also be starting relatively quickly. Jumps around a bit. Now the DRBD loader, for example, has finished the reports that it loaded the right DRBD version. And now the satellite is running and was already registered by the controller. So now if I run list node again, suddenly the satellites appeared because they registered themselves with the controller. And in LINSTOR, there's a concept called storage pool, which is basically which kind of storage backend you have available on your worker nodes. For example, that could be Linux LVM or a thin volume or ZFS. There are all kinds of storage pools supported by LINSTOR. But in any case, right now we don't have any configured. And that means we couldn't just create volumes right now. But there is a handy command for LINSTOR where you can basically see any devices you could use to create a storage pool. And I've created a 10 gigabyte volume for each of those virtual machines that I can use for my storage pools. And so I can create a storage pool for all of those nodes. Let's do an LVM thin one because I want to show snapshots later. And this device here. And we'll do that for every node. And if I check the storage pools again, now there's a storage pool configured every node with about 10 gigabytes free space available. So that's that. We have the satellites running, we have them registered, and we have given them some storage to work with. And now we only need to integrate it or need to build the bridge between Nomad and LINSTOR. And that is achieved with the CSI driver, which is unsurprisingly, again, a Docker container. And it's again running as a systems job. So it's run on every node. And since it needs to mount volumes, it needs to be privileged again. And then there's this special CSI stanza in the Nomad configuration, which basically tells Nomad that, hey, this is a CSI plugin, and you can use that to create storage. So let's run that last job again and see what happens. These are all runnings, and now there's the storage tab in Nomad, and pretty soon it should show all components as healthy. Okay, so now everything's up and running. The CSI plugin is registered with Nomad, and we can start creating volumes in Nomad. And for that, we need a new configuration file. And this is it. This is how you specify volumes in Nomad. You specify an ID. You can give it a name, but I've just chosen the same. You say it's a type of CSI volume and which plugin, in our case, LINSTOR. Then you can request a capacity. In this case, I force it to be 1 gigabyte. LINSTOR supports all kinds of sizes, so you can specify anyway anything you want here. Then we need to specify which capabilities this volume has, so should have. So the access mode single node writer means that this volume will only be usable from one node at a time. Doesn't mean that it will only ever be used on one node, but as long as something is using that volume, no other node can use it. And we want to create a file system volume because we want to use it in another container, and that expects a file system. You could also use a block storage volume here if you need block storage. And then you can specify which kind of file system you want on that volume and mount flags. And lastly, there's the parameters, which is the section where all the different things LINSTOR CSI or LINSTOR itself supports come in. First of all, we need to specify on which storage pool we want to use. This is the name of the storage pools I created earlier, so we'll use that. Then there's autoplays, which basically says, hey, this volume should be replicated so that the data is stored on 2 nodes instead of 1. And then the resource group is just for convenience. So, and now for this one, I'll need to use the CLI because that's not currently integrated in the Nomad UI, as far as I know. Let's create volume 1. And now it's registered here, and I've got here the basically a small dashboard of LINSTOR created that just watches all the different resources, and you can see that we created a new resource and everything's in a fine state, and that means we can start using it. For that, let's do another example job, in this case MinIO, which is basically an object storage which you might want to deploy in your cluster, and for that it is useful to have a storage volume. And in this case, we will request that we use the CSI volume we just created and run MinIO there. So let's do that. And this will take a bit longer because I haven't preloaded the MinIO image. As you can see, it's still downloading the image, but it should start soon enough. So now it is started, and also has its own web console, which you can use to log in, and I can just create some data there, just so you can see that it's actually working as intended. And if I move back to LINSTOR, you can see that the volume is currently in use on Nomad 21, and it's replicated the data across both of these nodes. And then there's the third node, which is an automatically created tiebreaker created by LINSTOR, just so that if one node fails, the other one can still access the data safely. Okay, so that's the using the volume. One thing you might want to do is creating snapshots. So there's a snapshot command for Nomad, which you can where you can specify that for volume 1, you want to have a snapshot created. And as you can see, it should be ready. And if you take a look at LINSTOR side, then you can also see that a snapshot was created here. And all the other components, this snapshot was taken while the application was running, so that's not a problem. And you can then use that snapshot to, for example, populate a new volume to, for example, if you want to restore something because something's gone wrong. And for that, let's move to volume number 2. This is basically the same specification as volume number 1, but up here I specified that I want to restore from snapshot number 1. And let's create that. Create volume number 2. Create it here. Create it here, restored from the snapshot. And now you can see here, the RBD is syncing the volumes. And let's say, show that here. So now everything's up to date and usable. And then we can use it, for example, for a second MinIO instance, just to check that it actually stored the data that should have been stored. Let's move to Nomad back again. Start it here. And again, it needs to download the image. But that shouldn't take too long. And now it should be running. And as you can see, this one was the old instance with the old date or the where we took the snapshot, and now there's the second instance which has the same data because we restored it from the snapshot. So that all seems to work as it should. And the last thing I just want to kind of demonstrate is, let's take, for example, Nomad 21, where we had our original MinIO instance running. If we now, for example, drain this node, then MinIO will be stopped here and will be rescheduled to another node, but it will still retain the old data because we've replicated it across all our nodes in the storage cluster. You see where it moved. Okay, new node, so it needs to download the image again. But if I connect to it and log in again, we still have the old data available. And that already brings me to the end of the demo. I hope you've learned something. And if you have further information, there are user guides for Nomad and LINBIT SDS, where you can find all the specifications I've used today. And with that, I'll hand back to Brian.
Yeah, we'll go ahead and open up the floor here for any questions, if anyone has any or comments. You can feel free to either raise your hand and I'll unmute your mic, or if you want to type it out, go ahead and do that.
I've got a question, Moritz, around obviously we've got these multi-region federation capabilities in Nomad. So I see that as, if you can do replication in LINSTOR across those multiple regions, it'd be good for, sort of a disaster recovery cluster, right, from storage and application perspective. So, I mean, do you see that as possible today with how LINSTOR is designed?
It's definitely possible, although I would say it depends on exactly how, I guess, how far away these regions are. There's obviously you will see a drop in performance if you're sending your data 3 times around the world.
Of course. And so is this asynchronous replication or synchronous replication?
Yeah, you can configure both. Mostly we do synchronous replication because that's mostly what people want. One thing you can also do, which I haven't shown today, is you can, these snapshots I demoed today, they only stay in the same cluster right now, but we also got a backup feature where you can where you can ship backups to X3 storage, for example, and later recover from there. And yeah, with automation, you can do that like every 15 minutes or whatever you need for your disaster recovery plans.
Nice. I can see some good possibilities in future there for that one.
We also support for S3 backup shipping. So you can easily ship the volumes to S3 backups, and then you can retrieve from that. That's also a backup policy, let's put it that way. Oh, Mr. Philip has a question, I guess.
Yeah, here's Philip speaking. You're just adding to this DR capabilities. So yeah, the snapshot shipping feature is really made for that. And it also supports to ship between LINSTOR instances. And what it does is that it can incremental ship differences between snapshots. So it gets really efficient, and it is made with the idea to federate, let's say, edge locations. Right.
So you're just doing the block changes in each snapshot.
Yeah, and only the differences between the snapshots then. So you would, yeah. So initially the volume is shipped once as a whole, right? And then every few minutes, it would ship the differences between the snapshots. And in case the network bandwidth isn't sufficient, you just miss one of those points, and it, then you get maybe 10 minutes instead of 5 minutes. But in that way, it always stays out of your IO path, and just makes what's possible with the network bandwidth. And yeah, so I would say that's suited for DR purposes. Okay.
Yes, so.
I don't want to hijack too much. Thanks.
Nope. You're always welcome. Okay.
Yeah, I also wanted to let the attendees know that we, next to the storage days that we run always with a partner, we also run our community meeting. We've done it now one time in December, but we're going to do it like once per quarter. And it's going to be basically like one of our internal meetings that we usually do between the European and the US office, where our developers share the latest features. We're going to host that openly and also invite everyone of the community and let them interact directly with us. And that next one is coming the 31st of March, so in roughly 5 weeks. Yeah, I guess there are no further questions coming in, so I guess we can wrap it up and yeah, call it a day.
All right. Well, thank you, Yusuf and Moritz and Thomas. And I guess we'll see y'all next time.